right, so this is page 2, and the nice thing about this example is that it tells us, right here, if you look carefully, it says it varies inversely. Okay, so when the directions say that they vary inversely, you know what formula to turn to. So the variables x and y vary inversely, and y equals 3 when x equals 6. So there's always two parts when you work this out. Okay, part 1 is the first pair. Okay, y equals 3 when x equals 6. That's what we're going to deal with first. Okay, so part 1. Okay, then it says write an equation that relates x and y, and then find y when x equals -9. So the equation is what we always usually find. Sometimes they ask for something else, but a lot of times it's the equation. And then the part 2 is always answering the question of finding something else. Okay, so this blue part is part 2. Okay, so let's first look at what we have. We know the equation, so that's y equals a over x, because that's inverse. All right, then we also know y is 3 and x is 6. So we use those two numbers in the equation. We take out y, and let's put in, it says it's 3. We take out x, and let's put in a 6. Okay? So we take out those two variables, and we use that first pair of numbers to put it into the equation. Then we just solve it, and we get that our constant is 18. Okay? And remember, constant means it's not going to change. So it's always going to be 18 in this scenario. So the inverse equation is 18 over x. So x and y can change, but 18 is that constant that we're looking for. And if you notice, all I did, pardon me, all I did was multiply the 6 over to the 3. And that's going to be a common practice when we're using inverse formulas, okay? So the inverse equation is 18 over x. So now let's answer the question. Find y when x equals -9. Well, all we do is we take the general equation that we just found. This is the general equation, and we could find anything. You could say when x is 20, when x is 15, when x is 1,000. It could say anything. In this case, it's when x is 9. So we go back, and we go back to that 18 divided by x, but instead of x, we put in -9, and that will actually give us the value of a 2. Excuse me, of a -2. Okay, so you put in the first pair of numbers that helps you find that general equation. This is the inverse equation, and then we can answer the rest of the part where you put in a new value to get out a new value, okay? And it makes sense. Since x went from 6 to -9, so x went down in value, that means that the y went up. It went from 3. Well, okay, it didn't, only because it's positive and negative. Positive and negative doesn't, it changes things up a little bit. So we can't compare like the fact that, you know, when we divide the mowing the lawn and stuff. But that's how we do it, is we use the formula, we put in the new value, and it helps us get a new value, okay? So now let's look at the next one. It's going to be similar. All right, let's go through and try it. It's going to be the same setup. Think of it as in two parts. The variables x and y vary inversely. So vary inversely means we're going to use y equals a over x. Okay? Y is 4.4 and x is 5. So we're going to use this pair first. That pair is then going to get us to our equation. That equation is then going to answer our question, okay? So, first thing I do is I take out y, and I put in 4.4. I take out x, and I put in 5. And then all I do is I multiply those two to get our value for y. So 4.4 times 5 is 22. And this is our constant. Okay, so now going back to the inverse formula, the x and the y can change, but now we know that the formula for this relationship is 22 over x. We know that no matter what the final question is right here, okay, no matter what we're being asked right here, we're going to use this formula, okay? So now we've got the equation because we used the first 2 points. So now let's go through and let's answer the question. Find y when x is 8. So now I just say, okay, well that just means I take 22 and I divide it by 8 and I will get 2.75. Okay, so there's a lot of parts to this. We use the first pair to get the equation. We use the equation to get to a new pair of numbers. So this pair would be 8 and 2.25. And then I could ask you about any x, and you could find any y, now that we found that generic equation for this problem, for this relationship. All right, so then the next one is just, it's a word problem, it's application, it's helping you see where inverse is seen and used. So, pardon me, man. Alright, so this is a pretty long one, but it says, determine whether m and n show an inverse variation. If they do, write a model that gives n as a function of m, find n when m is 45. So in the end, we are going to kind of do the same thing. We're going to find the equation, and then we're going to answer this last question. Okay? But what I will tell you is you might want to realize that, yes, an inverse variation equation is y equals a divided by x. That's what we've been using a lot. But if you noticed on the other 2 examples, to find a, we just multiplied x over every single time. We put the numbers in and we multiplied it over there. And then that always gave us our constant. So as a shortcut, if you always just want to take x and multiply it over, that will give us the constant every time. Okay? So that's just kind of a shortcut to find that constant, to find out what would go in that numerator. Okay? So when we have an inverse variation, that means that the constant is always going to be the same. Okay, so you want to actually multiply these every single time just to make sure that the constant is the same constant for every pair, for every relationship. So that's why right here they're saying, well, what's 5 times 45? And that is 225. Okay, well then what's, actually let me use a different color just so it stands out more. There we go. 5 times 45 is 225. Okay? 10 times 22.5 is also 225. 15 times 15, it's 15 squared, that's 225. 20 times 11.25, let's see, that's 225. And then 25 times 9, it's like saying you have 9 quarters, that's 225. So all we did was we just multiplied each of those. Each of these pairs, we multiplied. Because x times y, or in this case m times n, would give you that constant. So if you notice, the constant every single time is 225. So it is inverse because it stayed constant. That relationship between each pair stayed constant. So that is an inverse because every time we did it, it came out the same. So each product is equal to 225. So the data does, okay, they use the phrase do show. Okay, so it does show an inverse variation. Okay, so yes, it's an inverse variation. Okay, determine whether it shows, yes it shows. So m times n is 225. No matter what the pair was, we always got 225. Or we relate that to the inverse variation. That would be 225 divided by n, n, because that would be our x value. Okay, so this is the relationship finding the constant, but this is our inverse relationship. Okay, so then the final question right here. Let me do this in green. Find n when m is 45. I know that's hard to see on the board, but you've got it on your paper. So the value of n when m is 45 is 225 divided by 45, and you get 5. Okay, so you can't answer the question, but you have to take it in parts. Is there a constant relationship? Yes, there is. That constant gives us the equation. Now that equation helps us answer that question that we had at the end. Okay, so that is a practice of inverse. So now we're going to, you're going to practice one more time, and then we're going to talk about joint as well. Okay.